Hello everyone, good evening. So here we shall solve some more KCET previous year questions on chapter atoms. In the previous part of this chapter, we had solved till the question number 23. So in this second part of this chapter, we'll start with question number 23 onwards. So any doubts if you have in any solution, then please write that in the comments section. We shall clarify them in the subsequent videos. In any other chapter of physics, if you feel more difficulty, then write the name of the chapter also in the comments section. Then we shall give more clarity on it and solve more and more questions on that chapter. Also some important homework questions on the previous year KCET will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. In the question number 23, you can see that there are three energy levels. One is E, and the second energy level is 5E by 3, and the third energy level, that is 3E. There it is told, the figure shows the energy level of certain atom when the electron d excites from 3E to E. An electromagnetic wave of wavelength lambda is emitted. When the electron d excites from 3E to E, then there is some electromagnetic wave of wavelength lambda is emitted. Then what is the wavelength of the electromagnetic wave emitted when the electron d excites from 5E by 3 to E? So when the electron d excites from 5E by 3 to E, then what will be the wavelength? Let it be lambda 1. So then this lambda 1 I have to express in terms of this lambda. So now we can say that hc by lambda, that is equals to the energy 3E minus E. Therefore 1 by lambda, that is equal to 2E by hc. And similarly, the lambda 1, I can say hc by lambda 1, that is equals to the energy 5E by 3 minus E. Five by 3 minus E. So that is equal to 2E by 3. Therefore 1 by lambda 1, that is equals to 2E by 3 hc. So therefore I can see that 1 by lambda 1, that is equals to 1 by 3 lambda, means 1 by lambda into 1 by 3. So therefore lambda 1, that is equals to 3 lambda. Option A is the correct answer. Then in question number 24, it is told, which of the following spectral series of hydrogen atoms is lying in the visible region of the visible range of electromagnetic wave? So that is the Balmer series. Balmer series lies in the visible region. Lies in the visible range of the electromagnetic wave. So option C is the correct answer. And in question number 25, it is told, what is the energy of the electron revolving in third orbit expressed in electron volt? So here it is told that what is the energy of the electron revolving in the third orbit, means at n equal to 3. Then the energy is given as the 13.6 electron volt. It's 13.6 electron volt into 1 by n square. So this is the energy at the nth orbit. So therefore, energy of the third orbit, that is equals to so that will be 13.6 into 1 by 3 square electron volt. 13.6 by 9 electron volt, which is approximately equal to 9 1 to 9, 5 9 0, 45, and 10 9 1 0 9. So it is approximately 1.51 electron volt. So option B is the correct answer. So question number 26, it is called an alpha particle of energy 5 mega electron volt scattered through 180 degree by gold nucleus. An alpha particle is there. It means that it is the nucleus of helium He224. So its energy is 5 mega electron volt. So its energy means that it is the kinetic energy. And the alpha particle is scattered through 180 degree by the gold nucleus. Is scattered through 180 degree means that the angle of scattering then here the angle of scattering is 180 degree. Then the distance of closest approach is of the order. Distance of closest approach is of the order. Now we know that the kinetic energy of the alpha particle so the kinetic energy of the alpha particle, that is equal to K, that is equals to, you can say that is 1 by 4 pi epsilon naught the charge of an alpha particle here we have the gold nucleus. So its atomic number is suppose Z, so its charge is Ze plus Ze. The charge of alpha particle is plus 2. So therefore this will be 2e into, so the kinetic energy of the alpha particle, that will be equal to the potential energy of the alpha particle and the gold nucleus. Is equal to the potential energy of the alpha particle and the gold nucleus. So this K will be equal to 1 by 4 pi epsilon naught 2a into Ze by d. So which will be equal to 2ze square by 4 pi epsilon naught d. Therefore, where d is called the distance of closest approach, is the distance of closest approach. So therefore, the kinetic energy is given as 5 mega electron volt, and that can be written as 5 into 1.6 into 10 power minus 19 plus 6, that is minus 13 joule. So then therefore, for the gold, the atomic number for gold is 79. So the value of this Z is 79. And 1 by 4 pi epsilon naught, its value is 9 into 10 power 9. Therefore, I can say that this is 65 the 80. So this is kinetic energy is 8 into 10 power minus 13. That is equals to 9 into 10 power 9 into 9 into 10 power 9 into 2 into 79. 2 into 79 into e square. E square is 1.6 into 10 power 9 to 10 power 9 plus into 2 into 79 into the charge of the electron, that is 1.6 into 10 power minus 19, its whole square divided by d. Therefore, d is equal to 2936 18 into 10 power 9 into 79 into 1.6 10 power minus 19 whole square divided by 8 into 10 power minus 30. Therefore, d will be equal to 8 to 9 to 18. 9 into 79 into 10 power 9 into 1.6 whole square, that is 1.6 into 1.6 10 power minus 38 divided by 4 into 10 power minus 13. 4 4 is 16. Therefore, d will be equal to 4 is 64. So, if we solve it, that will be approximately equal to 4.6 into 10 power minus 14 meter. It is approximately 4.6 into 10 power minus 12 centimeter. So therefore, I can say that therefore the distance of the closest approach d, that is of the order of 4 that is of the order of 10 power minus 12 centimeter. So option A is the correct answer. And in question number 27, it is told, what is the wavelength of light for the least energetic photon emitted in the Lyman series of the hydrogen spectrum? What is the wavelength of the light for the least energetic photon, the Lyman series? So least energy means the least energy of transition. The least energetic photon will be emitted for the transition from n is equal to 2 to n is equal to 1. Therefore, the wavelength that is given as You know that hc by lambda, that is equal to 13.6 electron volt into 1 by n1 square minus 1 by n2 square. Therefore 1 by lambda, that is equal to 13.6 electron volt into 6. 1 minus 1 by 4, that is 3 by 4. So that divided by hc. hc is 1240 electron volt. Electron volt will cancel. Therefore lambda will be equal to 1240 into 4 by 13.6 into 3 nanometer. This will be equal to the wavelength lambda, that will be equal to approximately 40. So we get 12 and then the 36. 3 4 are 12, 3 1 are 3, 11, 3 3s are 9, approximately 4. So these I can take 4, so 400 divided by 4 approx. So 4 1s are 4, which is 12. So approximately it is 103 nanometer. So this will be approximately 121.6 nanometer, which is approximately 122 nanometer. So option D is the correct answer. And in question number 28, it's told that if an electron in hydrogen atom jumps from an orbit of level n equal to 3 to an orbit of, it jumps from level n equal to 3 to n is equal to 2. One electron jumps in an hydrogen atom. The emitted radiation has a frequency on it. So we know that 1 by lambda, that is equals to r into 1 by n1 square minus 1 by n2 square. And lambda, I can say this is equal to c by mu. But c is the velocity of light and nu is the frequency. So 1 by lambda is nu by c, that is equal to r to 1 by 4 minus 1 by 9. Therefore nu, the frequency of the emitted radiation, that is equal to rc into 1 by 36 into 9 minus 4, 5. So the frequency is 5 rc by 36. So option B is the correct answer. In question number 29, it is told the total energy of electron in an excited state of hydrogen atom is minus 3.4 electron volt. The kinetic and potential energy of the electron in this state is. So we know that the kinetic energy means the potential energy, that is equals to minus twice of kinetic energy. So the total energy that is equal to kinetic energy plus potential energy. So that will be equal to K plus minus 2K, which will be equal to minus of K. Therefore, here the total energy that is given, which is minus 3.4 electron volt, it is nothing but the negative of the kinetic energy. So therefore, the kinetic energy is 3.4 electron volt, and the potential energy that will be equal to minus 2K. The potential energy will be equal to minus twice of 3.4 electron volts, that is equal to minus 6.8 electron volt. Minus 6.8 electron volt. The potential energy is that is equals to minus 6.8 electron volt. So option B is the correct answer. And in question number 30, it is told when electron jumps from n is equal to 4 to n is equal to 1 level, the angular momentum of the electron changes by. So we know that angular momentum of an electron, that is given as nh by 2 pi. It is equal to mvr. mvr, that is equal to nh by 2 pi, where n is the shell number or it is the orbit number. N is the orbit number, and therefore the angular momentum at n is equal to 1. Let's say I say that the angular momentum for the orbit number n is Ln, so L1 that will be equal to h by 2 pi, and the angular momentum in the level n is equal to 4, that will be equal to 4h by 2 pi. So therefore the change in the angular momentum, that is equal to L2 minus L1, so it is equal to 3h by 2 pi. So option C is the correct answer. Then in question number 31, it is told the energy in electron volt required to excite an electron from n is equal to 2 to n is equal to 4 state in hydrogen atom is how much? The energy in electron volt required to excite an electron, how much is the energy required to excite the electron from n is equal to 2 to n is equal to 4 in hydrogen atom? So that energy, that is equals to 13.6 electron volt into 1 by 2 square minus 1 by 4 square. So that is equal to 13.6 electron volt into this will be 4, so 16 lines is 144. Sorry, yeah, 4 is there, This is 1 by 4 minus 1 by 16. So the LCM is 16 here. Then 4 4 is 16 minus 1. So therefore the energy that is equal to 13.6 electron volt into 3 by 16. So that is equal to 4 4 is 16, 4 3 is 12, 4 4 is 16. And 4 8 is 32, 4 8 is 32, 4 5 is 20. So this is 0.85 into 3, so that is equal to 3 5 15, 3 it's 24, 25. So 2.55 electron volt plus. So option A is the correct answer. Question number 32. Just told a scientist who is credited with the discovery of nucleus in an atom is Rutherford. So Rutherford discovered the nucleus of an atom. Rutherford is credited with the discovery of nucleus. So option B is the correct answer. Then in question number 20, in 33 it is told the total energy of an electron revolving in the second orbit of hydrogen atom. So the total energy of an electron which revolves in the nth orbit of a hydrogen atom, that is given as minus 13.6 by n square electron volt, where n is the orbit number. So therefore revolving in the second orbit, so we need to find E2. So that is minus 13.6 . So this is minus 13.6 into 2 square. So this is equal to minus 13.6 by 4 electron volt. So this will be minus 4 3 the 12. So minus 3.4 electron volt. So option C is the correct answer. In question number 34, it is told the period of revolution of an electron in the ground state of hydrogen atom is capital T. The period of revolution of an electron in the ground state of hydrogen atom, that is T. So T is equal to 2 pi r divided by V. So we know that the speed of an electron, the orbital speed of an electron, that is proportional to 1 by n, and the radius of the orbit, that is proportional to n square. So therefore the time period, that is equal, so that is proportional to r by v. It means that T is proportional to n square by 1 by n, that is n cube. So T is proportional to n cube. Where n is the orbit number in which the electron is revolving. So therefore T1 by T2, that is equal to n1 cube by n2 cube, I can say. So let's suppose T2 is T, when the n2 is the shell number and the orbit number, that is 1 here, n2 is 1. Since why it is told the period of revolution in the ground state means in the first energy level. So n2 is equal to 1. When n2 is 1, T2 is T, then T1 is how much? The period of revolution of the electron in the first excited state. So first excited state means n is equal to 2. N1 is equal to 2, then T1 is how much that we have to find. Therefore, I can say that T1 divided by T, that is equal to N1 cube. N1 is 2 cube by 1 cube. So this is 8. So T1 is equal to 8 times T. So T1 is equal to 8T. So option D is the correct answer. Then in question number 35, it is told, in Rutherford's experiment for head-on collision of alpha particles with a gold nucleus, the impact parameter is that for head-on collision alpha particles. So for the alpha particles, their charge is 2e. The charge is plus 2e. Charge is plus 2e and the mass of the alpha particle is 4m, where m is the mass of a proton. And for the gold nucleus, the atomic number is 79. So the charge of the gold nucleus, that is equal to 79e plus 79e. So then the impact parameter has been asked. So now, therefore, so when there is head-on collision, so impact parameter, it means that suppose this is the alpha particle and this is the gold nucleus, so then it will have some deflection. So then this separation is called as the impact parameter B. So when there is head-on collision, it means the alpha particle is in the same line as that of the gold nucleus. It means the velocity of the alpha particle is towards the nucleus of gold rod. So here the impact parameter is 0. Here the impact parameter B, that is equal to 0. So option B is the correct answer. In question number 36, it is told, frequency of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to. So the frequency of revolution, that is given as frequency is 1 by time period of revolution, and that is equal to the time period is 2 pi r by v. Now v is proportional to 1 by m. V is So the nu is proportional to v by r. So now, and the velocity or speed of the electron, that is proportional to 1 by n, and the radius, that is proportional to n square. Therefore, the frequency is proportional to 1 by n by n square, or I can say frequency is proportional to 1 by n cube. Therefore, option C is the correct answer. Then in question number 37, it is told a hydrogen atom in ground state absorbs 10.2 electron volt of energy. The orbital angular momentum of the electron is increased by. One hydrogen atom is there. Atom. So in the ground state, it will absorb 10.2 electron volt of energy. The orbital angular momentum of the electron is increased by. So it means that the electron will be excited to some shell number n, to some orbit n from its ground state. So then the orbital angular momentum, that is given as nh by 2 pi. So therefore I can say 10.2 electron volt, that is equal to 13.6 into 1 by 1 square minus 1 by n square. So 1 minus 1 by n square, that is equal to 10.2 by 13.6. Therefore 1 by n square is 1 minus 10.2 by 13.6, so that is equal to 3.4 by 13.6. Therefore n square is equal to 136 by 34. That is 2 17s are 2, 6 are 12, 2 8 is 16, 17 4s are 68. Therefore n square is 4, so n is equal to 2. Therefore the orbital angular momentum of the electron is increased by. So here this is Ln. So therefore the orbital angular momentum in the ground state, that is L1, that is h by 2 pi, and the orbital angular momentum in the first excited state, or for n is equal to 2, that is equal to 2h by 2 pi. So therefore the increase in the angular momentum, that is delta L, that will be equal to L2 minus L1. So that is 2h by 2 pi minus h by 2 pi, that is equal to h by 2 pi. Therefore the increase in the angular momentum L, delta L, that will be equal to h, that's equal to 6.6 into 10 power minus 34 joule second divided by 2 pi. So 2 into 3.14. So this will be equal to 6 on just 6. So this is approximately 1.05 into 10 power minus 34 joule second. So option B is the correct answer. Then in question number 38, it is told the d Broglie wavelength, the de Broglie wavelength associated with the electron, the de Broglie wavelength associated with the electron of the hydrogen atom in the ground state is, so lambda is equal to h by mv, mv is equal to so mvr, that is equal to h by nh by 2 pi. So mv, that will be equal to nh by 2 pi r. So this will be equal to h by nh by 2 pi r. So this is equal to 2 pi r by m. So it is the de Broglie wavelength for the nth orbit. Now, therefore, here it is asked to find the de Broglie wavelength for the ground state. So that is lambda 1, that is equal to 2 pi r. And the radius of the first orbit, that is equal to a naught for first orbit, the radius of the first orbit. So that is equal to 0.53 Armstrong. So that is equal to 2 pi, 2 into 3.14 into 0.53 Armstrong. So that is equal to, that is 6. So this is approximately equal to 3.3 Armstrong. So option D is the correct answer. In question number 39, it is told a beam of fast moving alpha particles were directed towards a thin film of gold. The parts A, B, and C of the transmitted and reflected beams corresponding to the incident parts A, B, and C of the beam are shown in the adjoining diagram. The number of alpha particles n. So in which point the number of alpha particles is maximum and in which part it is minimum. So we know that most of the rule is that in the alpha particle scattering experiment, the alpha particle scattering experiment, what happens? The observation is, the first observation is, most of the alpha particles went straight through the, will go straight, so they went straight through the gold foil without suffering any deflection. Went straight through the gold foil without any deflection. Without any deflection. And then the second thing is that a very small fraction of them got deflected by large angles. A very small fraction, a very small number of them got deflected through large angles. Small fraction of them got deflected through large angles. So it means that here at the point A dash, the number of alpha particles in, therefore the number of alpha particles in the point A dash will be maximum, and at the point B dash it will be minimum. at point B dash it is minimum. So it means that here none of the options are correct. Here none of the options are correct. Then in question number 40 it is told the period of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to the time period of an electron revolving in nth orbit of hydrogen atom. So the time period is given as 2 pi r by v, and r the radius of the nth orbit, that is proportional to n square, and the velocity of the nth orbit, that is proportional to 1 by n. So the time period of revolution, that is proportional to r by v, or I can say the time period is proportional to n square by 1 by n, or I can say it is proportional to n cube. So option A is the correct answer. So T is proportional to n cube. Then in question number 41, it is told that the angular momentum of an electron in hydrogen atom is 3h by 2 pi, where h is the Planck's constant. The kinetic energy of the electron is the angular momentum of an electron in the hydrogen atom, that is 3h by 2 pi, and the kinetic energy of the electron. Okay. So we know that the angular momentum of the nth orbit, that is given as nh by 2 pi. So therefore here n is equal to 3. So the kinetic energy of the electron in that orbit, that is given as 13.6 by n square, that is 3 square. That will be 13.6 by 9 electron volt. That will be equal to 9 1s are 9, 5 9s are 45, and 1.51 electron volt. Option D is the correct answer. And in question number 42, it is told that energy of an electron in the second orbit of hydrogen atom is E2. Energy of an electron in the second orbit of hydrogen atom is E2. So it means that it is minus 13.6 into 1 by 2 square. The energy of the electron in the third orbit of helium plus ion will be. So we have to find the energy of the third orbit, E3, for He plus ion. So for helium, the atomic number Z is 2. So that will be minus, so that will be minus 13.6 into Z square by n square, Z square by n square. So that will be equal to, from here we can see that minus 13 points, this much electron volt. And from here E2 it is equal to minus 13.6 by 4 electron volt. So therefore this minus 13.6 electron volt, I can call it as 4E2. Therefore from here we can see that E3 for helium, that will be equal to this minus 13.6 electron volt into 4 by 9. So that is equal to 4E2 into 4 by 9, that is equal to 16 by 9 E2. So option B is the correct answer. Then in question number 43, it is told the figure shows standing de Broglie waves due to the revolution of electron in a certain orbit of hydrogen atom. The figure shows standing de Broglie waves due to the revolution of electron in a certain orbit of hydrogen atom. Then the expression for the orbital radius. All notations have the usual meanings. So the orbital radius for the nth orbit in a hydrogen atom, the orbital radius of the nth orbit in hydrogen atom, that is given as Rn. That is equal to n square epsilon naught h square by pi m e square. N square epsilon naught h square by pi m e square. So how it comes? It comes like this: is mvr, that is equal to nh by 2 pi, and we know that mv square by r, that is equals to 1 by 4 pi epsilon naught into e square by r square. R will cancel. So then from here you can see that mv square r, that is equal to e square by 4 pi epsilon naught. So mvr, that is, so nh by 2 pi into v, that is equal to e square by 4 pi epsilon naught. So cancel. So the v will be equal to e square by 2 epsilon naught nh. Therefore r, that will be equal to nh by 2 pi into 1 by mv, 1 by m into v. V is e square into 2 epsilon naught nh. So 2 will cancel. So therefore from here we get r is equal to n square epsilon naught h square by pi m square. It is the radius of the nth orbit of a hydrogen atom. So now the de Broglie wavelength for the nth orbit, that is equal to h by mv, that is equal to h by nh by 2 pi r. Okay. So this will be equal to 2 pi r by m, the nth orbit. Is that 2 pi r, that is equal to n lambda. It means the 2 pi into r, it means the circumference of the nth orbit, that is equal to n times the wavelength, n times the de Broglie wavelength, where some standing waves are formed. So here, so it means that in the nth orbit, n number of standing waves are formed. The nth orbit, n number of standing waves are formed. Standing waves of the electron wave is formed. So here, how many waves have been formed, that we have to find first. So here we see that here one wave, two wave, three waves, four waves, five waves, and six waves. So here n is equal to 6. Since here 6 standing waves are formed. 6 standing waves are formed. So therefore here n is equal to 6. It means that it is the sixth orbit. So therefore here the orbital radius. Therefore here 2 pi rn, that is equal to 6 lambda. Since here 6 standing waves are formed. 6 standing waves of the electron wave is formed. So therefore n is equal to 6. So therefore the Rn is the radius of the sixth orbit. Radius of the sixth orbit, that is equal to 6 square epsilon naught h square by pi m square. So that is 36 epsilon naught h square by pi m square. So it means that here none of the options are correct. So none of the options are correct. Then in question number 44, it is told an electron in an excited state of lithium Li2 plus ion has angular momentum at 3h by 2 pi. The de Broglie wavelength of electron in this state is p pi a naught, where a naught is 4 radius. The value of p is so according to the Bohr quantization condition of the angular momentum, according to the Bohr's quantization condition, for the angular momentum, is MVR or L. L is equal to nh by 2 pi. It means the angular momentum of the nth orbit. For the nth orbit, it means I can say m into Vn into Rn, where m is the mass of the electron, Vn is the speed of the electron in the nth orbit, Rn is the radius of the nth orbit. So angular momentum of the nth orbit Ln, that is equal to nh by 2 pi. So here the angular momentum L, that is given as 3h by 2 pi. So it means that n is equal to 3. So it means that it is the third orbit. So it is the third orbit of the Li2 plus ion. It's the third orbit. So it is the third orbit of Li2 plus ion. Then the de Broglie wavelength of the electron in this state L, that is equal to h by mv. So that I can write r into r, I can write. So that is h into r, Rn by mvr, that is L. So the radius of the third orbit r3 divided by L, that is 3h by 2 pi. So that is equal to 2 pi into r3 by 3. So r3, the radius of the third orbit of lithium ion. of Li 2 plus n. That is given as this a naught n square by z, a naught n square by z, and Rn that is given as a naught n square by z, where z is the atomic number of that hydrogen-like species. So here z is equal to 3 for lithium. So this will be equal to a naught n square by 3. So that is equal to 3 a naught. So therefore lambda 3 is the de Broglie wavelength for the third orbit for lithium ion, that is equal to 2 pi into R3, that is 3 a naught by 3. So that is equal to 2 pi a naught. So therefore the value of P is equal to, since that is given as P pi a naught, so P is equal to 2. So option B is the correct answer. And in question number 45 is told, in accordance with the Bohr's model, the quantum number that characterizes the Earth's revolution around the Sun in an orbit of radius 1.5 into 10 power 11 meter with orbital speed is 3 to 10 power 4 meter per second is how much? Given mass of Earth is this. So here we have to apply the Bohr's quantization condition. According to the Bohr's quantization condition, for angular momentum, that is given as mvr, m into v into r, that is nh by 2 pi. So we have to find the quantum number of the Earth's orbit around the Sun. It means we have to find that what is the orbit number for the Earth. If you consider it to be a Bohr's model. So now therefore m is the mass of the electron in the orbit around the nucleus here. So here we should consider m as the mass of the Earth, since here Earth is moving around the Sun. So Earth is considered to be an electron. Mass of the Earth into the velocity, the orbital speed of the Earth around the Sun, and the radius of the Earth's orbit around the Sun, and that is equal to n into h by 2 pi. Therefore mass of the Earth, that is 6 into 10 power 24 kg, into the speed of the Earth, that is equal to 3 into 10 power 4 meter per second, and the radius of the Earth, that is 1.5 into 10 power 11, that is equal to nh by 2 pi. N into h is equal to 6.63 6.6 into 10 power minus 34 divided by 2 pi, that is 2 into 3.14. So then this n is equal to n is equal to 6 into 3 into 1.5 into 2 into 3.14 into 10 power 24 plus 4 plus 11 divided by, which is 6.6 into 10 power minus 34. This is approximately 1, this is 1.1. So n is approximately 4.5 into 2, 9, 3 is 27. So this is approximately 2.8 into 10 power is 28, 39 plus 34, that is equal to 73 or 73. Two 0.5 into 2, that is 9, is 27. Okay. So this is 28 in approximately. So this is approximately 2.8 into 10 power 74. So which is approximately 2.57 into 10 power 74. So it is of the order 10 power 74. So option C is the correct answer. So this is the quantum number for the Earth's orbit on the Sun. Then in question number 46, it is told the electron is revolving in its Bohr orbit. An electron is revolving in its Bohr orbit, having Bohr's radius of 0.529 angstrom. Then the radius of the third orbit is. So the Bohr orbit means it is the first orbit of the hydrogen atom. Bohr orbit means it is the first orbit of hydrogen atom. So therefore the radius of the third orbit that is equals to, so this is actually a0. You know that r is equal to a0 n square by z. So for hydrogen, z is equal to 1, Rn is equal to a0 n square by z. So r3, the radius of third orbit, it is equals to a0 into, so r1, that is equal to a0, which the radius of the first orbit is a0. So that is equal to 0.529 angstrom. And r3, that is a0 into 3 square by 1. So that will be equal to 9 a0. That is equal to 9 into 0.529 angstrom. That is approximately equal to 27, 4.77 angstrom approx. So which is approximately 4.761 angstrom also, I can say. So option A is the correct answer. Then we shall solve the last question. So in question number 47, it is told the radius of the hydrogen atom in the ground state. The radius of hydrogen atom, the radius of the nth orbit, that is given as a0 m square by z. That is, so for hydrogen atom, z is equal to 1, means the atomic number is 1, and for ground state, n is equal to 1. For ground state, n is equal to 1. It means that in the ground state, the electron will revolve in the first orbit. So therefore, r1, that is equal to a0, and that is equals to 0.53 angstrom, it has been told. After collision with an electron, it is found to have radius 2.12 angstrom. The principal quantum number n of the final state of the atom is. So therefore, after collision with an electron, the electron gets to some excited state. So let's say that state be n. Let the principal quantum number of the first state be n. So therefore, Rn, that is equal to a0 into n square for hydrogen atom. and that is equal to 2.12 angstrom. So from here n we have to find. So therefore n square will be equal to 2.12 angstrom divided by a naught, which is 0.53 angstrom. So angstrom and angstrom will get cancelled. So this is 212 by 53. So this is equal to 4. So n square, that is equal to 4. So n is equal to 2. So option D is the correct answer. So hope all of you have understood the solutions of all the 47 questions in this chapter. And any other doubts if you have, then please write that in the comments section. We shall clarify them. And please install our Sapience education application, where we shall upload some important homework questions on the previous year KCET exam on every chapter. So thank you everyone. Bye.